Hey everybody, welcome back to Mr. Murray's Mathland, and today we're taking a look at another classic free response question for AP Calculus, and that would be problems that have to do with data given to you in a table. And it's almost certainly one of the 6 free response questions every year on the AB Calculus AP exam, at least, and usually on the BC as well. Um, so let's just take a look at what we got here. And I made this problem up, but it's very similar to years of looking at old FRQs. That they're all fairly similar. So this one represents a baby tree is 7 inches tall when planted. Its height in inches is modeled by the twice differentiable function. That just means the derivative exists and the second derivative exists. It's kind of a qualifier they throw in a lot of problems, so there's no discontinuities or cusps or anything. Where t is the number of months after being planted, and certain values are displayed in the table below. It is known that h double prime of t is greater than 0 for all t. So they threw that in there. That may very well may be important later on, because they often will do things like this, and we'll see that when we need it. So we have this table, and part A is a fairly common kind of a warm-up question almost. So this should really be a softball in these kinds of problems. Using correct units, approximate the value of h prime of 6. So this function that's in the table is h, and we want to estimate the value of h prime at a value, and that would be the derivative at 6, and the derivative gives you the rate of change, or the slope, at 6. And of course, there's nothing about 6 in the table, but that occurs right here, exactly halfway between 5 and 7. So the best way to approximate what that instantaneous slope would be is to do the average rate of change, or the slope of the secant line, with the 2 surrounding points. So we're just going to do the slope, really. This is really just some algebra 1 kind of stuff here. y2 minus y1 over x2 minus x1. H of 7 is 22, and I like to show the calculations when I do these with the function notation. I don't know, I just think it looks a little more polished. And then you get 8 divided by 2, and that would be 4, but notice it did say using correct units. And so the units on this, if you're not sure what it would be, you can always just take a look at the units of the numerator. And so h is measured in inches, and you're dividing by x, which is t in this case, and that's measured in months. So your rate of change, your derivative, is going to be inches per month. Okay, and that should make sense. And the understanding of that helps you to explain the meaning of h prime of 6, which is, sometimes asked as an accompanying question. So I like to say this, whatever you're measuring the rate of change of, which is h in this case, and that's height. So you want to cite both the time value, in this case it's 6. So I'm going to start my sentence that way. At t equals 6 months, and always try to include units, the correct units in the problem. At 6 months, at t equals 6 months. And h prime is the rate of change of h, and h is the height. So I'm just going to kind of translate that into words. The height of the tree, that's just h, is, and because the derivative was positive, that means the h is increasing, it's going up. So I always try to incorporate the word increasing or decreasing, depending if my derivative value is positive or negative. So the height of the tree is increasing at a rate of 4 inches per month. There you go. And you're showing that it's only like at that moment that it's that rate of change, and that's what derivative is, instantaneous rate of change. So it should be a pretty easy, straightforward question to get a couple points, get the ball rolling on this question. And so let's take a look at the next couple parts. Part B, using correct units, explain the meaning of this in the context of the problem. So you've got this definite integral from 0 to 8, but notice you also have this 1/8. And hopefully you could recognize that as being the average value theorem. That's the setup for finding the average value of h of t over this interval of 0 to 8, looking at the limits of integration there, 0 to 8. And when you recognize it as average value, it makes it much easier, I think, to sort of translate into what this thing represents. So 1/8 of the definite integral 0 to 8 h of t dt is the average, and that word's got to definitely be included, but rather than saying the average value of h of t, just use the units of h of t. What does h of t represent? Height of the tree in inches. So this is the average height of the tree in inches. So you just said it's the average value of h of t, basically. And you always want to say over that interval, over the interval or between 0 and 8 months, over the interval t equals 0 to t equals 8 months. You could really just say over the first 8 months after being planted, something to that effect. But it's nice to use that word average in there and to specify that it's over that specific interval in some way. Okay, and now part C is now going to ask you to approximate the value of this definite integral using some kind of Riemann sum or trapezoidal sum in this case. And that's almost always one of the three parts. It's usually a left, or a right Riemann sum or a trapezoidal sum. Occasionally they'll throw in a midpoint one maybe. Just notice in this case that it's not just the value of the definite integral. It's also, you've got that 1/8 there, that average value theorem. So 1/8 0 to 8 h of t dt is approximately, I like to write approximately because we are estimating. If you write equals on the AP, that is fine. 1/8 of, and now I'm going to do that whole trapezoidal sum for the definite integral on the inside. So if you're a little rusty with your trapezoid area, remember trapezoidal area is 1/2 height b1 plus b2, right? And these intervals are not equally spaced. The delta x does not remain constant. It's a width of 2, it's a width of 3 right there. So you have to use individual trapezoids, but no big deal here. The first interval is 2 units wide. That is the height, because remember, these are kind of trapezoids turned on their side like that, where those vertical lines, the y values, are the bases, and the height is your delta x. Okay, so the first trapezoid is 1/2 of that delta x of 2 times the sum of the bases, which are 7 and 8. 7 plus 8. Hopefully by this time when you're doing FRQs in preparation, you're pretty comfortable with things like trapezoidal rule, because it's going to be there, and it's really not too bad if you practiced it. 1/2 for the next trapezoid, that delta x, that height of 3, and those bases are 8 plus 14, plus 1/2 the next width, which is 2, and the sum of those bases are 14 and 22. And the last trapezoid is just a delta x of 1, and the sum of its bases are 22 and 28. A little scrunched in there on the end. Okay, and if you're preparing for the AP exam, you know that you can leave things entirely unsimplified. Don't waste time simplifying this big long thing. You could leave that as a final answer. Boom, as far as the value of it. You don't have to simplify a single thing. I'm going to simplify it just to, come up with an actual number, but it's really just something to know going in, that's a huge time saver sometimes. So unless there's a need to simplify it, like you need to know about the value of it in some way, you need to do something with it. So this first one is going to be 15. The next one is going to be 33. When we take half of that, 22 times 3. Half of 2 is 1 times that sum of 36. And the last one, that one that's squeezed in there, is 22 plus 28, 50, and then half of that is 25. And so you're getting 1/8 of all of that added up should be 109. And 109 divided by 8 inches. Remember, this is representing the average height. And if you were to divide 109 by 8, you get 13, I think, and something. And that would maybe make sense. That would be a number that seems in the ballpark for what the average height of this tree might be over this interval. And it didn't specifically ask for units on the answer, but I always like to, you never know. They can take off points even if it doesn't specifically say to include units. And lastly, for this part C, is this very common question about your Riemann sum or your trapezoidal sum. Is this approximation more or less than the actual value of the interval? And this is going all the way back to that little piece they gave you in the beginning, that the second derivative there is positive. Okay, so if the second derivative is positive, that means h is concave up. And if the graph is concave up, a trapezoidal sum will overestimate the area, which is the value of the definite integral. And if you, again, you don't just know that, you can usually kind of recreate it, just draw a sort of a generic concave up graph and draw any trapezoid. When you draw a trapezoid on a concave up region, it's always going to be over the curve, so that area of the trapezoid is going to overestimate that area, under the curve, which is what your definite integral is going to give you. And so always make sure to answer the question clearly, though. It said, is your approximation more or less? So I always like to just make sure it's absolutely clear. Therefore, our approximation is more. Now, if it's a yes or no question, say yes or no. If it's more or less, say more or less is more than the actual value. Okay. And I threw in a part D, but those first three are really super common with these. And with a lot of FRQs, when you get to the third or fourth part, then they might throw in a curveball or something that's a little bit different. And so, I don't know, this is just something you might see, this sort of thing. This isn't as guaranteed. You never know what's going to come up, so just prepare as best you can. But if you've gotten this far, you've got a good chunk, 5 or 6 out of 9 points. You're ahead of the game. So part D here, we have now, they're telling us about a second tree. A second tree has been planted at the same time as the tree we've been dealing with all problem. And the height of the second tree is modeled by g of t. Same deal, t is measured in months. And we have the equation for the derivative, the first derivative of g. And we know that the second tree is 11 inches tall at t equals 1 month. So that is telling us that g of 1 is 11. The height at 1 is 11 inches. And it ultimately is asking which tree is taller at 8 months. Okay, so we need to know how tall is each tree at 8 months. We already should know that for the first tree, that because you just look at the table at 8 months, that's what this is showing you. The height is 28 inches. So you just got to know how tall is the second tree, taller or shorter than 28 inches. And so this is a kind of a classic way to incorporate, a little integration here, a little antiderivative. I'm assuming, this would be a non-calculator kind of question. That's the way I've approached this, at least. We have this equation of 4 over the cube root of t. and that is 4t to the negative 1/3. I'm getting ready to integrate because I want to create g's function so that I can figure out what g's value is at 8. And so here we go. If g prime is that, then g of t is going to be the integral of 4t to the negative 1/3 dt. Always try to use proper notation. And now we've got this is pretty straightforward kind of power rule. So add 1 to the exponent, and that becomes t to the 2/3, and now divide by 2/3 or multiply by 3/2, and that will give you 6t to the 2/3. But this is an indefinite integral, so do not forget about your plus c, that potential constant on the end. And now, how are we going to find that c? Because we need to know it if I want to know what the value at 8 months is. I can't have that extra constant hanging there, but that's where I'm going to use this point. So this is essentially a differential equation kind of problem where you're finding the particular solution. Using that point they've given you, I'm going to plug in 11 for y and 1 for t. A nice convenient value. You're welcome, everybody. And we have that's 1 to the 2/3 is 1, so c is equal to 5. And now that c is equal to 5, we know the full equation of g of t is 6t to the 2/3 plus 5. That's that constant we just figured out. And so why did we want this in the first place? So that we would know what's the value of g at 8. How tall is this tree after 8 months? And so now you got a little more of a fun value. And yes, you're allowed to leave things unsimplified, but in your mind, you want to know, is this value more or less than 28? So it requires at least a little simplification in your head, if not writing it out. So order of operations here, you got to do that 8 to the 2/3, and remember that is the cube root of 8 squared, and always do the cube root part of it first. Easier. Cube root of 8 is 2, 2 squared is 4, 6 times 4 is 24, plus 5 is 29. So g of 8 is 29 inches, and so you can see that that c value gave you just enough to push it over the height of the first tree. So again, let's make sure we actually explicitly answer the question. The second tree is taller at 8 months. And in your work, you've clearly shown what the first tree's height was and what the second tree's height was. So feel free to write more if you need to, but that's pretty good there. And so that's one FRQ kind of broken down, and hopefully you feel pretty good about it. So hang in there and keep working hard.